Okay, GM everyone. Hi, David. So great to have you here with us today. Hi, everyone. So great that you're joining. Welcome. So yeah, let's dive right in. And hi, Blessing. So great to have you here. Very excited to see your project. Yeah, let's get started. So today our workshop will be about Build with Olas. You will learn how to implement AI tools from the Olas MECH to improve the UX of your dApp. And we have David here from Valerie, who is building Olas, and he will show you how to implement an AI tool. But first, let's get a quick overview for everybody. Oh, Helene, so great to have you here as well. Wow, I love it. So let's get started. First of all, we always start with our goal, our motto, and that is building with purpose, building for all. Yeah, just a little intro for everybody who is new to Celo. I think a lot of people are also joining here today to learn more about Ola. So quick intro into Celo. Celo is a layer 1 EVM compatible blockchain. We are mobile first, and one of the main very cool things about Celo is that you can pay gas fees in stable coins. Currently with CUSD and USDC and coming soon, and USDT has just been voted for today in the governance forum to be approved. So as a gas fee, so that is very revolutionary and very cool and very accessible. So we are very excited for that. And also very important, transaction fees on Celo are very low. You only pay 0.001 CUSD, USD per transaction. So you can build very scalable, very accessible applications with offering also to pay gas fees for your users. So just in general, a chain to build purpose full applications on. So why build on MiniPay? We say build for why build on Celo? We will say build for MiniPay. And for everybody, again, MiniPay is a browser wallet that you can open up in Opera Mini Beta. And it is very lightweight, only 2 megabytes. And you can what is so special about it? Again, it has stable coins for gas fees, so you pay in CUSD for gas fees. It has a very Web 2 feeling, and the cool thing is because it's integrated into a browser, it has a possible distribution network of 80 plus million users, and the Opera team in general, like MiniPay, has been built for Web 2 users. So the whole narrative, the whole design, and the whole user experience is very Web 2. And that is kind of, I think in Web 3, we built a lot for Web 3 users, which is not building for mainstream adoption or for banking the unbanked. So this is a very amazing example of onboarding a huge, a lot of people to Web3. Opera Mini is mainly distributed in Africa, and MiniPay currently is accessible, which means it has on and off ramps in Kenya, in Nigeria, and in I'm normally know the third country. I'm sorry, but we will soon also be in a lot of more countries, and sorry. So what is also very cool for building for MiniPay is that you have access, through having access to this distribution network, you have not you don't have to deal with challenges that come with normally having to like promote your application. And because Opera Mini already is 2 million users strong. Check out our, I will share links later for you to check out how to install MiniPay and more. But also the reason why we're having this hackathon, this workshop today is the Build with AI Transforming Personal Finance Hackathon. You can scan the QR code to sign up. And let me also, of course, share the link with you now. And it is focused on building with AI, which is why we have Olas here today, and which is why we are very excited for this hackathon. Just to give you an overview, the hackathon kicked off last Friday, but you can still apply. You can join our Discord or a Telegram channel that I will also share here. The Discord I will. Okay, I will share everything after when David is talking. So I'm not stopping now, but I will share all the links. You can still sign up. You can still find a team or hack solo. The hackathon runs for like 12 more days. It has a prize pool of 10K CUSD, and we have 2 tracks. The first one is Build with AI, integrate Olas. And we will talk about the bounties after this workshop a bit more in detail. But the second track is building for MiniPay. You can apply for both of these tracks. And yeah, just a little overview about what's coming up. We have the hackathon, the workshop today of building with AI tools. And next week, Tuesday, same time, same day, we will have our second workshop with Olas, which is how to build with AI agents. We also have our first milestone check-in tomorrow, so make sure you check your emails because you will receive an email after this. And to submit your first milestone, don't worry if you just joined today, you can just submit your idea and say that you still look for a team, and we will try to help you find a team. 21st are submissions, and then the judging and winner announcements on the 25th. So now let's get started with the fun part. Very, very excited to welcome David on stage. David will introduce to you today how to build with AI tools, and I will go move your screen to the stage. Yeah, welcome, David. Please start.
Excellent, and thank you for the warm welcome, Lena. All right, so as Lena said, I'm David. I'm a software engineer. I've been working for almost 3 years with Valerie team, which is a core contributor of the Olas protocol. And let me just kick it in starting by making a very brief introduction of what Olas is. So just in case some of the audience is not aware of what the Olas protocol is. So we like to think of Olas as a 3-legged stool for generating autonomous services. And I'll come back to what an autonomous service is in a second, but it's important to have in mind that there's these 3 sides to the equation, which is Olas is a protocol, it's a stack, and also an ecosystem. So this protocol is deployed to several different chains, including Ethereum, Celo, Novosis, Polygon, Arbitrum, Solana, Optimism, and Base. I hope I am not missing anyone there. Then, apart from the protocol, we have this open source stack to code and create autonomous services. The name of this stack is Open Autonomy. and we will see more on that in a second. And then, of course, we have this rich ecosystem of different autonomous services and agents that are running these applications in a decentralized way. So what is an autonomous services, you may ask? And basically, we like to think, or when we talk about autonomous service, we refer to a piece of software that runs continuously, can take action on their own. And in this case, it has a wide range of applicability. Since these agents run off-chain, they are suited to build from oracles to relayers, messaging layers, interacting with a smart contract, automating any kind of smart contract calls, and as we are focusing on today, also building some AI tools and AI focused agents, right? So this is a unique approach. Basically, what we have been seeing in the space so far are things like traditional web services that are usually flexible, and we might say that somewhat intelligent, but lack this crypto nativeness. We also have smart contracts which are in this other side of this triangle, that they are flexible and crypto native. And then we have the usual automation and oracles, for example, Chainlink, which are crypto native as well and intelligent, but maybe less flexible. So we are building something in between these kind of autonomous services that are, let's say, crypto native, intelligent, and flexible enough in order to be a good foundation in order for us to implement robust architectures for off-chain operations. Okay, so this is a bit of a summary of what we have until now. We have 426 minted services on the Olas protocol so far, which have performed more than 500,000 transactions on different chains. And we have from messaging services to DeFi, DAO tooling, automation, oracles, or the thing that where we are focusing on today, AI services. And I want to bring your attention to this first service here, the AI MECH, which is the ones that we will be using for this hackathon. And this brings us to what is an AI MECH. And for this, let me finish my presentation here and open this other document that I have handy on the back of my screen. So a MECH, as I was saying, is one of our autonomous services. I mean, anyone can run their own MECHs, but we usually have like the most popular one is the one that we are running ourselves on the Valorant side. So you can think of MECHs as on-demand brain for your applications. MECHs is an autonomous services that listen for any kind of requests and send some response back through the chains. And basically, we need this kind of agents because at some point, other agents might want to interact, for example, with ChatGPT or Stability AI or any kind of other intelligence APIs or tools out there. But we certainly don't want our agents to be paying for multiple different API access. So we can think on the MECH as a hub where we can borrow some of this intelligence by paying a small fee. So we send a request with some small payment to the MECH. As an example, we could send some request like, please use ChatGPT to evaluate this prompt. And the MECH will perform this action for us and will send the response back to us without us needing to set up any kind of API subscription or anything. So basically, MECHs implement this, what we call these MECH tools, which are these small pieces of code that implement all these behaviors, and agents can pay to borrow and use these tools. Anyone can implement their agents, and anyone can implement their own MECH tools. So the actual, what happens when someone sends a request to the MECH is somewhat complicated. Don't worry and don't get afraid about this diagram. You don't need to understand what's going on, and you certainly won't need to do anything of this because we have taken care of that for you, but it's important to keep in mind what is going on behind the curtain. So let's say, for example, that we have an application like this one here, this blue box here, that wants to make a mech request. So what in a traditional setup this application would do is to pay for API access, for example, for OpenAI, and send a request to OpenAI backend and get the response, right? In this case, it's a bit more complicated. So what we do is to write our request to IPFS in a JSON object, and we get back an IPFS hash that we write to an on-chain contract. This will trigger a chain event, and here we have our small mech service here listening for all these kind of chain events. So at some point, this service will listen for this chain event and will figure out that it needs to send a response back. So the first thing it does is it goes to IPFS using the IPFS hash it got from the mech contract, and it pulls from IPFS the request that the application had uploaded earlier. And now inside that request, you have specified some tool that you want to use. For example, in this case, we will be using OpenAI tool. So the mech figures out it needs to use the OpenAI tool. It loads it dynamically. It sends a request to OpenAI API. It gets a response back, and then the process repeats, but the other way around. Basically, it writes the response to IPFS. It gets a hash, and it then writes the hash to a mech contract. And then your application will be listening for this chain event, will get the IPFS hash of the response back, will go to IPFS, and we finally, after so many steps, get some response back. So yeah, this looks very complicated, and I won't lie, it is. But as I said, you don't need to know or interact with any of these things. We have a library for you that you can use inside your application, and that abstracts away all this complexity. So maybe I can start by showing you the repository of this library, which is called mech-client. We will provide some links for this. And I think it's easier to understand what we are doing here if I start by using this library to run an example prompt. So let me pull my VS Code here and open the README. These instructions that I'm going to follow are written on the README, but anyway, I will prepare a virtual environment here. I will install this library, and I will send a request to the mech, so you all see how this works. The first thing you need to take into account is that you need to have installed Python 3.10 or higher, and then you can basically start already. I will start by first creating a new virtual environment, which I'm going to call Celo Hack. And I'm going to go into this folder. And since my computer is running an old OS, I need to verify that, yeah, that's it. This is what I was saying. We need to run with Python 3.10 or higher, but I have 3.8. So it got that by default. So let me update this file. So I am ensuring that this is the version that will be used. And now I can already install the library. So I'm inside the virtual environment now. And the first thing I want to do is to add the mech-client library. Let's give it a couple of seconds until the library is installed. And that's it. We are ready to go now. So how do we use this library? So the interface is pretty much easy. One thing that we need, since if you recall, I said before, we need to pay for these requests. even if it's a very, very small amount. Currently, the fees for each request to the mech is 1 cent. And for that, I need to set up a private key and fund it. In my case, I already have some private key, but you can use something like MetaMask or any other wallet that you use. You can export your private key and store it in a TXT file like this one, Ethereum private key. The name does not matter. I just call it that way because that's the default name this library uses. And one important thing to take into account is that this file should only contain the private key, no extra spaces, no extra tabs or extra endlines, just the private key. Or if not, we could have some issues when loading the key. In my case, my key is already on this directory and has some Celo on it, so I can use it right away. And then we'll need to you won't certainly need to do this, but in this case, due to some issues we had today, I need to use a custom WebSockets endpoint. So I'm going to export this environment variable. Let me move this out of your site for privacy 1 second while I export this WebSocket RPC. All right, it's done. So I now have a custom WebSockets RPC endpoint. But there's a default one in this library, so you won't need to do that. And now we can already send our first example. This is the syntax. So we use mech-x interact. We write a prompt, and then we specify a number. This number is the ID of the mech, which we will be calling. There's several mechs deployed to several networks, and there's a link in this README with all the addresses and all the IDs. I know that the Celo mech is number 2. So I'm going to copy this and paste it here. And I am going to edit this and I'm going to use the ID number 2. Then I'm going to specify the key file. I have it on my home folder. So here it is. Now we specify which tool are we going to use. There are multiple tools. Some are for using ChatGPT, others for trading strategies. There's no limitation on what we can implement in a given mech tool. In this case, I'm going to use just a simple ChatGPT request. And then I'm going to change. Yep.
Can I, after this, can you show how people can also find out quickly what other tools are available?
Yeah, I was going to do that later, but yeah, I can do that.
Okay.
I can do now.
No. I think I don't want to interrupt your flow. Please continue. I think that's perfect if you show it later.
Okay. Yeah, I thought that maybe we just use the most popular one and then we can go over the rest of them. So there's different ways of confirming the response. One is on-chain, another is off-chain using subgraph. In this case, I'm going to use on-chain confirmation on Celo. And since we have not deployed the subgraph yet for Celo, this is the only way to do it on Celo right now. So this is it. I'm going to use the prompt, number 2 for the mech, private key, the tool, and then I ask it the confirmation to be on-chain on the Celo chain. So I'm ready to send this now. And here we go. The first thing, as I said, our prompt has been uploaded to IPFS. So if I click here and open it, we go into the Olas gateway for IPFS, and we can see that we have stored a small JSON object there, which includes the prompt, the tool that I have requested the mech to use, and then there's a nonce, which is a unique identifier for each request, and that's it. Now I go back to our terminal. We can see that, yeah, that's it. We can see that then we have sent a transaction including this prompt hash. And at some point, the mech already got the request and sent a response back. And so here's what we're getting back. This is a small JSON object as well that includes the request ID, and this is the result. This is the nice little poem that the mech has written for us, next to other objects like the prompt that we have used and other things that are not relevant for this example. But here's how you would do it. You might notice that this request is not especially quick, and since you need to take into account that since this goes through several transactions, IPFS storage, and then we have the call to openAI API, it might take from 45 seconds to several minutes if the mech is overloaded in worst days. You could be looking at maybe 2 to 3 minutes of waiting for the response. And then, that was the simple usage of the mech-client as a terminal tool. But then we can, of course, use this library from one script or one application, which I think is the most interesting way of using, right? So let's say, for example, that we want to repeat the same example, but not from the command line, but from a Python script. So let's focus on this small script that I prepared for you. The only thing we need to do is to import the library, and we prepare some prompt in this case. And to do a somewhat different example, I am going to use another different tool. We will see now after this other tools, but I am going to use the prediction online, which is a very popular tool that trader agents use to make predictions on predictions markets. So I am going to write this question here. Will the Federal Reserve impose interest rate cuts by 12 April 2024? And then I am specifying that I'm going to use this prediction online tool. I am going to use the Celo chain, and the agent ID is number 2. Basically, this is the same data that I passed on my previous command, but from this script. And then we just send this all this data to the interact method, which takes the prompt, the agent ID tool, chain config, confirmation, and the private key path. So if I go into the folder where I have this, and I run the script, test mech tool, I can run it already, and you see that the interaction is basically the same. We have a prompt uploaded. There he is, the prompt, the tool that we are using, prediction online, and then the nonce. And we go back here. We got a transaction request ID already. So every time we make a request, we get an ID, a unique ID using this nonce. And there we go. This tool is a little bit more verbose than the previous one. As you can see, there's a lot of data there, but here is the thing we should focus. I have asked a question to the mech, and the response of this tool, this prediction tool, is basically the probability of the answer to be yes or no. So the mech seems to think that with 70% of 70% of probability, the Federal Reserve won't impose any new interest rate cuts by April 12th. And then, of course, there's a lot of other information here, like the prompt we used, the tool as well, and lots of other things that are not relevant for the example. And this is the other way of using the mech tools. And now let me check my notes, because as Lena was saying, I think it's interesting now that we have a look at what tools do we have and where can we find them. So mech tools are small code packages that live inside the mech. And for that, we have this repository, which is mech. We will also provide a link for this. And if you go into the packages, you will see that there's several other folders here from different contributors. One of those is Valory, but you have there's Polywrap and other ones. And whoever implements a new tool will create a new folder here and add the tools inside. In my case, I'm going to go into the Valory folder. Then I'm going to go into Customs, which is the only relevant folder for this workshop. Inside Customs is where all the tools implemented by Valory live. And you can see that we have here prediction, request embedding, stability AI request. This one, the one that I used on the first example, openAI request. So when you open one of these tools, only 3 files live inside. One is just a simple, almost empty init file that you can forget about it. It does not implement anything inside. Then you have the actual implementation, which is the Python script. And then there's some configuration. Configuration is usually auto-generated for you when you run the tools. But just for you to see.
Can you zoom in a bit?
Yeah.
Yeah, that's perfect.
Can you see it? Okay. So basically, this is a simple YAML file that just has the name of the tool, the name of the author, the version number, and so on. It's not very interesting at this stage, and all these fingerprints are automatically generated. So you only need to take care of the description and author name and so on. But the really interesting part lives inside the Python file, which is this one. But before I actually show a complete one like this, let me show another very simple example of what a very simple dummy tool would look like. So can you see should I make this bigger maybe? Better this way? Okay.
Yeah, like this is perfect.
So as you can see, this is a really simple Python script that just implements one method, which is called run, that gets some keyword arguments, and then it returns 4 different things. Whenever we use a tool, we basically are calling this run method, passing all the arguments like the prompts and everything that's needed for this tool inside here. So we usually do something like this. From the quarks, we get the prompt and we store it in a variable like this one. We might get other things from the quarks. In this case, I just kept it simple, and that's it. At this point, I could implement my tool's logic. Oops. In this case, my logic will be just this dummy response, okay? Let's see, here we could be calling other libraries, ChatGPT, make some wild predictions using some strategy evaluation. Everything that you want to do goes here. And you, at some point, you calculate a response that you want to send back to the agent who has requested this tool. And then at the end of your function, you return 4 different things. The first one is the response that we have calculated. Then optionally, this is not mandatory, but I was doing just for the sake of showing how to do it. I will be sending the prompt back. And then there's these 2 different objects that you don't need to use. I don't think anyone will be using that, but just for the sake of completeness, let me explain. First one is a transaction, which is basically if one tool was meant to make a transaction in behalf of the agent that called this tool, this is where we would send the transaction back. And then some tools might require to calculate some costs, which is not the case for the most popular tools. So we usually send none back. So you can forget about these 2 objects and only take care of the response, which is the important thing. Whenever you want to test a tool like this, you can do it locally. For example, we could do the usual if name equals main, then run, and I will send in my quarks the prompt equals by prompt, and then I can, for example, here define a prompt as a dummy prompt, right? So I could go to, I am already inside the folder. So if I run this script, my dummy tool, well, I actually would like to save the response and then print it so I can see what happened. And when I run it, you see that basically this is a very simple basic function call. So I am getting some dummy response back. So this is a way to test first, to locally test your mech tools before actually sending it to the mech, because at some point you will have a complete mech tool that you will want to be inside the mech, and for that you will need to open a PR in this repository we've been looking at, the mech one. So you would push a new branch and you will open a PR that includes your own mech tool here with your implementation, and then you will tag the maintainer of the repository and maybe me as well, so we can review, and then we can merge the tool so any other agent can use it. Of course, anyone can run their own mech with their own custom mech tools, but I think the most easy and quickest way to have your own tool running on a Mac is to do it on the Mac that is already used by anyone and run already. Then I think, let me think if I am missing something. Yeah, this was an example of a very simple dummy tool, but as we were seeing on the repository, there's a lot of other tools. So let me show you what the OpenAI tool looks like, and I'm going to start from the bottom of the file. So you are now already familiar with this run function that I show you on the dummy example, and here we do a bunch of other things. This tool is going to basically use OpenAI library as well. So there's a lot of parameters that we need to extract from the quarks, and this is the first thing we do once we enter the run method. We use the quarks, we get max tokens, temperature, prompt. If a user does not provide any of those, we have some default values for that, so you don't also need to focus on that at all. And we also have some...
in a question, because it came from the audience and maybe it fits very well here now. So Blessing asked, like, what is the maximum amount of tokens that can be processed? Maybe I'm not sure if that's the question, but like I think probably there is a lot of like blockchain transaction, you can give a maximum in case it goes over that and you don't want to pay more, right? Or like what is max tokens in this case? What does it stand for?
That's
the temperature.
So that totally depends on OpenAI. It's not, I mean, since we are storing everything on IPFS, that is not a problem for us, just for actually paying to OpenAI. So we can see that here we are using a default value of 500 max tokens as default. You can change that. I don't have the exact number for the max, but this should be on OpenAI's documentation. It's completely up to them. And then we are using the temperature of 0.7, but you also can change that according to OpenAI.
So all of these are inputs for that. This is just inputs on parameters for an OpenAI request that you get from like the documentation. Okay, so this is just OpenAI specific. Okay.
Yeah, in this case, I decided to show this tool because it's a simple proxy to OpenAI's API. So we are using, as you can see here, we are just importing their Python library. And so that's why this script is so simple. This tool is so simple. We basically get the user's input, the prompt, every parameter. We check for invalid values and all kinds of things. And then we basically call the library with the parameters that the user has sent in the request. And then we craft a response and send it back. It's simple as that. There's no magic in it. I can show you that at some point we use this wrapper class around the library to just instantiate the libraries, passing the API key. This can be copied and pasted by anyone that wants, for example, to use the same library. But there's no more to this than this small piece of code. You can see that's less than, the main thing is less than 50 lines of code, basically getting the parameters right, and then calling the library. It's just that. Of course, you can make this as complicated as you want. You can have like 1,000 lines of code, mech tool that does all kind of crazy things. Of course, that's up to the participants, to the hackathon, to decide how complex they want to do it. But I would start by basically having a very small thing. And for that, we have prepared another tool, which is the prepare transaction. We might go into more detail next week on this one. But since we are doing a Celo hackathon, and we thought it would be nice if, for example, we could have a tool that prepares transactions for us. It does not settle the transaction, but basically listens for requests made in using natural language. For example, I would like to send one Celo to Lena or to this address. So this tool is, you can think of this as a template to work on top. It's called prepare transaction or prepare underscore tx. And then it does mostly the same as the OpenAI tool, with slight different that we are using this prompt on top, which basically explains to the LLM that you are an LLM inside a multi-agent system that takes into account, explains lots of things about how to create transaction data from a simple sentence like transfer one way or one Celo to Lena. And then it will send a JSON object back, like, let me search for it. Sorry, I think I scrolled too. Well, like this one. It's a simple transaction JSON object that just includes two addresses. Like here, we would have the address of destination, and then it would calculate the value. So we could have a service that listens for HTTP requests. We will talk about more in detail about that next week. But a simple service that listens for HTTP requests using natural language, like, yeah, please send this to whoever, and then the service would make a request to this tool. This tool would prepare the transaction and will send it back to the agent, who in the end will settle the transaction. So we would magically have like a transaction out of nowhere, just using our voice or text. And I think I'm almost over time. So I think that's most of the things I wanted to talk about. Maybe Elena, you have or some questions from the audience?
Yeah,
or...
I already have one other question, and I think that goes into the question I had earlier. So, like in your first prompt, right, you defined like if you can open the file where you programmatically called the mech-client.
Yeah, this one.
Yeah,
right?
Because like here you define this, you put in like tool name prediction online, and before you put the tool name OpenAI 3.5. Where can people find the list of the tools that you have available on Celo?
All right. So if we go into the mech repo.
Yeah.
Oh, you mean, sorry, can you repeat the question? You meant all the
the tool, like where can people find all the tools from the mech-client that are on Celo? Like
all
how
the
can
tools
they
are
find?
everywhere.
Yeah.
So there's
Okay.
no tools are not restricted to a specific chain. All the tools are running everywhere. So if a tool is in this repository, for example, if you go into packages, Valerie customs, all these tools here are available on Celo. But we can also go into packages, and I don't know, Polywrap. Polywrap has implemented prediction with research report. So I go into here, and then this tool is also available there.
And then, so I just take the title of the Wait, now I didn't find it. Yeah, maybe you can just provide me with the link so I can add that to our documentation later.
We'll do
and
that.
Then, so we basically just put in the name. And then one of the question was, thank you so much. That is amazing. We have the link here in the chat as well. And yeah. So this is, okay, cool. So you will also find it in the README under included tools. So one of the question was, is Gemini already integrated? Or would somebody have to use the template, like to build it? That could be one of the submissions.
Yeah, completely. As far as I know, there's no Gemini integration, so that indeed would be a really nice addition to create for the hackathon. And yeah, anyone that wants to interface with any other LLM, like Gemini can, for example, get the OpenAI tool and use it as a template and modify it. I don't think it would take a lot of effort to make it work with Gemini, and I would definitely like to see that working.
Yeah. Okay, cool. Nice. Very, very cool. Then I will, thank you so much. I think that was great. Let me get some more questions. So where do we find the IDs for the agent? You said the Mech has the ID 2. How do, like, for example, or do you think this is something like right now we teach people how to implement the Mech, so that's the ID 2, and next week we will explain them how to find the IDs for all the different agents?
Well, since I think the IDs are here in the docs. Wait for a second. Yeah, here it is. At the bottom of the Mech README, there's a list of all the deployed agents on all the networks. As you can see, there's one single Mech for each network. So for Celo, we are using number 2 here. So I think everyone will be using number 2 for this hackathon, since this is running on Celo. But if at some point anyone wants to use any of the other ones, here's where we would find the IDs.
I think that already leads me to my next question, because I see you have like nevermind pricing and fixed pricing. And I think that would be a question, like you now said, like you pre-funded your agent wallet with Celo. Can people pay for the whole interaction with the Mech in Celo, or like do they need any other currency to pay for that interaction?
So currently there's 2 ways of paying for requests. The most popular one, and the one that I always use, and the one that I showcase today, is basically paying in Celo. I think it makes a lot of sense to pay in the native currency of each chain. So what I did today is to pay in Celo. But whoever thinks he's going to use the Mech tools a lot, there's this other alternative, which is setting up a Nevermind subscription, where you basically pay beforehand. You have this amount pre-assigned to you, and then you can basically spend all your subscription there. But I don't think that was as interesting as paying in Celo for the hackathon. That's why I showcased the most common approach.
Okay, cool. Yeah, I think it's just, I think for the hackathon with Celo, it's perfect. I think just in the future, if people want to implement that in production, of course, it makes more sense to do I think it's just to understand that it's also, there's like a subscription model. I think that's very useful. And that's in USDC, right? The Nevermind pricing?
Yes, it's 1 cent, 1 USDC cent. I need to check, but I think so. Yes.
Okay, cool. That is amazing. Then we had another question from the audience that was like, if Olas supports image generation.
Image generation. Let me think. I am not aware of all the Mech tools.
We just got an answer in the chat. There is one that supports image generation. It uses Stability AI.
Yeah.
And wait, let me pin this quickly.
I think.
It's, yeah. Yeah, I know there's also a lot of people in Web3 that develop this like AI, like video from AI. So that would be a cool thing to implement.
Very cool.
I feel like for Olas. Oh my God, I need to write a friend right now.
Yeah, here it is.
Yeah.
Here it is. I just found it. Yeah, I wasn't remembering, but yeah, we have in the Valerie the stability AI request. So here, you might find something interesting to work with.
Okay, amazing. That is very, very cool. And yeah, Blessing, maybe you can say if your question has been answered. That was like, what is the maximum amount of tokens that can be processed? Can you maybe explain your question more in detail? But yeah, I think so. Like for testing, how much would you pre-fund your wallet? Just like one of the things I think that we need to mention is Olas is only deployed on mainnet. So if you implement Olas, you will have to deploy your application on mainnet. And if you need some if you need a tiny amount of Celo, please reach out to me and I will send you like half a Celo token. But that should be fine because as you heard, it's like 1 cent that you have to pay for one request. So yeah, I think that was one important thing to mention. Maybe I will share again, like if I will wait for questions. Just some more resources. Everybody, if for the hackathon, if you have any questions, please join our Discord with that link. You can just do chat. I also posted it here. I will also send all of you an email afterwards. If you haven't signed up for the hackathon, please do so. The link is in the chat, but I will also send it. Let me send it again. This is the link to the hackathon. If you haven't done it, please join. We already have amazing teams. Some of them are still looking for Python developers, and so feel free to reach out. We are also I know we have some Python developers here today, so please join Discord, introduce yourself, and also fill out the form that I will share later with you, so I can help you find a team. And we also have this Telegram group here, up, where you can just ask quick questions, because I know that Discord can sometimes be a bit difficult to navigate. So please also join this group. We have another question. Is it possible to use Olas for checkouts in the e-com store? The question is, what do you mean with that? I think if you can define that more in detail, if I understand it right now, you would want somebody, like, it makes more sense, I would say, for like language, like natural language processing, right? Like if you do a checkout, you mean like you want to have somebody talking or writing and like giving natural language instruction for then doing like a transaction or a swap. So I think if you want to do a checkout in an e-commerce store, you mean just somebody asking you, do you want to pay now? I think for any action that has to do with AI and requires some backend action, I think actually you can make that happen. Yeah. So, but then let me think, David, do you have?
So
how would
the
you
way
implement that into the checkout of an e-commerce? I'm not sure.
when we say checkout here, we mean like,
Yeah.
as you said, pay for this or whatever,
Yeah.
or is it? Yeah, I mean, there's nothing preventing you from doing that. Although I feel it's more interesting when you actually have to borrow some intelligence from the mech. I mean, uh, I think the interesting thing here is, yes, that it's not like the agent implements everything uh, itself, but it borrows some intelligence, some brain from the mech. And for taking a decision like pay for something, you actually don't need that. Or that, as I see it, you already have decided that you want to pay, or I don't know. Of course, nothing prevents you from implementing any kind of logic in a mech tool. But yeah, I think more interesting use cases here is something that is really like, like the example we provided earlier today, like, please prepare a transaction for me and do it automatically. That's it. But of course, you can implement some checkout thing as well.
I mean, if that is like your first interaction and you just want to try it out, just implement it. I think that's a good first step. And then you can, I think, go from there of like how it can actually support you. What I also wanted to just share with everyone is the workshop that is happening next week. It will be how to implement and also modify agents. So what you saw today were AI tools, and next week we see how agents can use these AI tools to like be independent actors on the blockchain and like make decisions based on I guess we saw like the simple example for like, is this happening or not? And then you can say, do this transaction if this is happening, like prediction agents, right? And based on some kind of prediction, you can also implement some kind of like swapping or trading functionalities and transfer functionalities. So we will get into that next week. We think this was already, AI, like using AI in general to do kind of like user incentives. I think that is ultimately the aim, to like use in MiniPay, right? To like really understand how do you incentivize people. How do you like react to specific user behavior, not like for a huge crowd, but like how do you analyze each individual user behavior and then react to that with recommendations, with maybe reduce pricing and like adding that into your shop. That would, and having like agents that borrow from different sources of data and decision making, and then influencing that. I think that is the ultimate goal of like having an agent that could make a very complex decision and smart decision on, I mean, how, so definitely thinking about developing an agent, but that is more complex. So how can you think of something that is the first version of that you can in the future add more functionalities to? Because like for this hackathon now, we assume you, like, if you want to build your own agent, you are probably able to implement one function, and then but yeah, what you could do is like create an agent that reacts to your on-chain behavior and see, for example, that you have used MiniPay a lot, and then you analyze on-chain behavior. But we are currently working on developing a new, and like there is, I think, agents that do already check on-chain behavior, but I don't know if we have one on Celo yet. But we will get one on Celo, and that will help you like to maybe reward users for on-chain behavior. But I know there already is an agent that also analyzes off-chain behavior. but I'm not sure if that is on Celo. David, do you know?
Not that I am aware of.
Okay. No, that is coming for our future hackathon. So be on the lookout. This is kind of for everybody who is joining. We have this is a series of 6 hackathons. So this is the first one, and we want this is our first introduction for you to Olas and implementing Olas, and we will provide more agents and more tools for you also in the future. So just putting also here in the link for next week's event. And yeah, thank you so much. I think I will just share again the links that we had here for Olas today, but you will all also receive a mail with all the links and resources that we shared today. And yeah, make sure to reach out if you have any questions. You can find, of course, all the information for that Celo developer resources in our Celo docs. And then you can reach out to me on Twitter and find me on as Gigahertz and ask me all the questions you might have. And other than that, I see you on Telegram or on Discord. You can also find David on Twitter under this name. Let me just share. And then also, oh, that is not the right thing. So this is how you can find us if you have any questions. And we also have another answer. So, to Blessing, you could use an Olas agent for checkouts, especially if the store has an API. So don't necessarily you wouldn't need the mech tools, but you would create like your own agent that uses the API of the store, and then it would be like a token distributor agent. And yeah, we will share more on agents next week and how you can build your own agents that react to things. Also, in general, if you're interested in building more agents, reach out to me, because we want to see a lot more agents on Celo. So we want to support you in building them. So yes, David, do you have anything else to share? Thank you so much for joining. It was very, very amazing. I think it was a very great workshop and everybody learned a lot. So yeah.
All right, yeah, nothing more on my side, and thank you for having me. Like, very excited to see what everyone, everyone is building on Celo and Olas.
Cool. Thank you so much. Yes, very, very excited. This will be fun. Thank you everyone for joining today. Have a great evening and day. Bye.
Bye, everyone.